So this is just going to be a quick demo, quick run through of my final year project. So a micro world to help with the teaching of the scientific method. So I suppose just to really quickly start off, it's composed of two experiments that run from they scaffold the user through each step of the scientific method process from background research all the way up to results publication. So there's two experiments here. One is the effect of environmental factors on tree growth, and the second one is a bit more abstract, the effect of music on how many eggs a chicken lays. So I suppose we'll just start off with the first one. It's a bit more straightforward and easy to follow. So the first stage is background research. It gives the user a list of variables down the left-hand side that they have the freedom to test throughout this micro world. So it gives effects of soil pH on tree growth, water, sunlight, etc. So the user is supposed to sort of get a background research on these different variables and how they affect the experiment that they're going to run. So the next step is variable identification. So in a science experiment, there's three different variables. There's your independent, which is the thing you want to change in your experiment. So you want to measure the effect of your independent variable in an experiment. You have your dependent, which is the thing you want to measure. So in this context, we want to measure the tree height, and your control variables. So things that affect your experiment, but you don't necessarily want to test them in this run through. So it gives the user um, a bit of freedom here. It lets them choose what they want to test and how it affects tree growth. So let's say the user has done their background research and they think that sunlight exposure has a big effect on tree growth, and they want to test that in this run through of their experiment. So they select that as their independent variable. They also think that water availability has an effect, but they want to keep that constant, so they select controlled for this, and maybe as well we'll go for soil pH as well. So as you can see, just places them in and sort of separates the variables into the three distinct categories. So this is the stage 2 variable identification. So after that, in the scientific method, you form your hypothesis. So it's an educated guess on what you think might happen during the running of your experiment. So let's say our user hypothesizes that a certain amount of hours results in taller tree growth than, uh, let's say 8 hours. So 10 hours of sunlight will result in a taller tree than 8 hours of sunlight. So a pretty standard hypothesis. So they formulate this. It's up to the user, depending on the variables they chose in the first stage, or the second stage, I might say. And it's up to them to choose a hypothesis that they want to test in the experiment. So then you get into your actual experimentation. So it allows the user to select how many trees they want to monitor and the amount of times they want to run it. So let's say they want to have 7 trees in each group and they want to simulate it 4 times. So since we selected our independent variable as sunlight, we now have to select in the control panel our independent variable. So it says here this is our experiment group, so that one wants 10 hours, and this is our control or our comparison control panel, and they wanted 8 hours as we selected before in the hypothesis. So now we want to run our experiment, and it takes a few seconds, and it will bring us on to the next stage, which is our results. So to the best of its ability, the model predicts or it calculates tree growth in meters over time based on based on the variables that the user selects. So it gives a graph. So on the y-axis it's height, and on the x-axis it's time in years. So our blue graph is the tree with 10 hours of sunlight, and the red or pink is just with the 8 hours. So the user can see here that there isn't that much of a difference between the two, or the independent variable, in terms of 10 hours and 8 hours of sunlight. The model also predicts random events, so stuff like storms and droughts and etc. So it has some sort of real world variability in there. The user can see the amount of time. So there's obviously they selected a set amount of times they wanted to run it, so they selected 4, I believe. So yeah, they can see now that there seems to be some effect of sunlight. So 2 hours more sunlight each day will result in slightly more growth over the time period. So the user will then select their conclusion. So what do these results tell us about what we hypothesized? Um, this drop down here, it sort of covers all possible conclusions that you might draw based on your results. So in our case, 10 hours does result in larger tree growth. We now select, does this prove our hypothesis? Does it disprove it? Or might we need some more data, or might we want to rerun the experiment more times to see if we get more conclusive data. So maybe they might think that their hypothesis is proved, since that they see a number of times that the growth has increased. So that is what the user might do. So then they publish their results. So it gives them a sort of mock paper, gives them some sort of conclusion, some sort of I suppose value to their work. It puts it sort of simulates them publishing a paper. So yeah, they puts in a sort of discussion, conclusion, the graphs that they got, etc. And yeah, so that is the first experiment. It then gives you sort of an overview here of whether your hypothesis was proved, your conclusion, etc., etc., etc. It gives you your controlled variables that you chose, so water and soil, and the ones you didn't choose, which is it's quite influential, this one. Do you think that so it gives you sort of an overview of the experiment you ran, and sort of you might have a discussion with your instructor about sort of the limitations of your experiment and what conclusions can be made. So that is the first experiment. It's quite linear. It's quite easy to understand for the user. So then we go on to our more abstract one, the chicken one. So then again, it runs through the same process of background research. So effective presence of music, type of music, the breed of chicken, etc., etc., etc. Same again, our variable selection. So let's say the user thinks that they did their background research. They think that actually the volume level of the music has a big effect on the amount of eggs a chicken will lay. And they also, let's say they want to keep their duration the same, breed of chicken, environmental conditions, diet, stress, and age of the chicken. So those are our control variables, things that influence the experiment, but you don't want to measure them. You want to keep them constant. So then again, our hypothesis is the same. So, but this time we want to measure volume of the music. So let's say they hypothesize that medium volume will reduce in less eggs compared to high volume. Okay, so that's what the user hypothesizes. So now this is our experiment. You're allowed to choose how many chickens in each group and how many days you want to run it over. So quite similar to the previous one. Okay, so our results page. So this is, I'll talk about it in depth now. So it gives you an average, the average eggs produced per day by the two groups. So it says here that there's a slight difference between the chickens listening to medium level music as opposed to high level music, or high volume music, excuse me. So the user might conclude now that actually medium volume music is better for egg production than sort of high volume music. So what would our conclusion be? Yeah, so our conclusion or they might conclude that it might be marginal. However, it does consequently affect the amount of eggs a chicken lays. So let's say the user predicts that or concludes that. Does this prove our hypothesis? No, it doesn't, since we hypothesized that it will result in less eggs compared to high volume music. So we'll say it disproves. Okay, and on this experiment, it's slightly different than the previous one. It says that we only received sort of average results there, and that we might need some more complete data to sort of draw a more conclusive hypothesis. So it prompts the user to go back and say, do you want to run this experiment again and measure more in-depth sort of results? And you might get a sort of different conclusion from there. So then again, brings us back to the sort of experiment page. They can run the experiment again with sort of different variables this time, but it's the same. So medium volume versus high volume. So it gives us more in-depth results here. So it gives us eggs produced by the two groups per day. It's up to the well, it depends on the discussion we're having with the group and the sort of the discussions we have out of that. But they see here more in-depth results. It seems a bit more random, but again, it says that medium volume music results in more than high volume music. But it opens it up to discussion whether about how sort of the effect of results on sort of experiments, etc. So we have our previous conclusion here. Do these new sort of does this new data sort of tell us anything more about how we, or sort of the conclusion that we made beforehand? Since it says here that medium volume music results in more than high volume music, we'll probably conclude that. So let's conclude that. Does this sort of support our hypothesis? What was our hypothesis again? It will result in less. So we'll say again that it disproves it. But it depends on sort of the user, etc. They might conclude that these new results, they sort of it's more concrete. They now think that they now thoroughly believe that the hypothesis is disproved. So then again, they publish the results, some sort of sense of achievement in what they've been doing, and they publish that. And same again, it gives you sort of an overview of the actual experiment you ran. So here it says your hypothesis wasn't actually disproved, and that your conclusion was that chickens listening to medium volume music produce more eggs over time than listening to high volume music. And it gives you some results. Your control variables that you chose and the ones that you didn't, and it's going to open it up to some discussions about reliability of results and the need to repeat sort of experiments multiple times, etc., etc. But that's sort of an overview of sort of the tool and how it might be used in a sort of educational context. But yeah.